Okay, so a very good evening, everyone. So we are into the 13th lecture, and in today's lecture, we are going to discuss the anomaly detection. Okay, so in the last lecture, we have started discussing the basic definitions of the anomaly detection. And we have also established that anomaly detection is a difficult problem, right? Because there are a lot of things that need to be taken care when we are designing the solution for anomaly detection. So in today's class, we will be discussing the algorithms that can be used to identify anomalies in the social network. So after that, I will try to, revise the syllabus after midsem. So in the last class, I have got this request for a review session. So I'll quickly try to revise the portion that we have covered after midsem. And like in the last lecture, that is on next Saturday, so I will try to cover the syllabus that was before midsem. Okay, so with that, we will start with our today's lecture. Okay, so these were the definitions that we have covered in our last class. So firstly, so I hope I'm audible to everyone and my screen is visible. Okay, so firstly, let us discuss what is anomaly. So anomaly is a pattern in data that does not conforms to the executed behavior. So what does it mean? That in the social network, suppose we have the communities. So the nodes in this community will be behaving in a certain way, but then there can be certain nodes in the same community that are behaving differently. So such nodes can be called as anomalies. Okay. And in this lecture, we will be seeing that how you detect these anomalies. So these anomalies are also referred to as the outliers, surprises, exceptions, and so on. So these are the different names with which you can call the outliers. Okay, the branch of data mining concerned with discovering rare occurrence of data sets is called as anomaly detection. Okay, so this problem is a high impact problem. Why high impact problem? Because we know that like in social networks, sometimes we have this fake news that is being spread. Okay, so these fake news can have a huge impact on the companies, on the stocks of the companies. So we need to, figure out who is spreading the fake news and we need to stop those fake news. Then again, we can have the credit card frauds and the different frauds that we can have. In the website like Amazon, Flipkart, Myntra, we can have fake reviewers of the products. So those fake reviewers need to be identified and need to be removed. Okay. So otherwise, the companies might affect their products and their marketing might be affected because of these fake reviews. So that's why this problem has a huge impact on the economy and it is a very important problem. So these were the different applications that we have already seen in our last class. And then we have discussed what is the difference between outliers and graph anomalies. So you know that in data mining, we have the definition of outliers. So like how it happens in data mining. So we have these points and these points might have like a huge number of attributes. Okay, so this can be a high dimensional data. So what we try to do, we try to plot this high dimensional data into two dimensions that can be drawn using dimensionality reduction techniques. Okay. And once we draw these points or this data on two dimension, we can then identify the points that are behaving differently. Okay. So this is how outliers are identified in the data. But when we have the social networks associated, when we have the network data, the data related to like which person is connected to which other person. Okay, so when we have relationship data along with the attributes, so this problem becomes little more complicated to solve. Why? Because we need to consider these connections and these structural properties when we are trying to identify the anomalies. Okay, so with that, we can say that this is a very challenging problem. And you know that there are different applications. So there can be one application that is like fake news spread, and there can be other application like we need to identify the fake reviewers, or then can be a third application where we need to identify the anomalous behavior of a student in a class. Okay, so these all are different types of problem, and for these different types of problem we need different types of algorithm. So at some point, in some examples, we need to only consider the structural properties of the network, and based on the structural properties of the network we can identify that whether a particular node is behaving differently or not. For example, like I might have a network, and in a network, so I might have some a network, and in network there is one node that is being maybe connected to all the other nodes. So on an average, the degree of all the other node is maybe 2 or 3, but this node has a huge degree that is, for example, 100. Okay, so let us assume that there is one node whose centrality is huge. So this can be considered as an anomalous behavior based on the structural property. So here we are not considering the attributes of the node itself. Okay, we are not considering that, okay, what is the name of this node, what is the area it belongs to, what is the age of this node. So we are not considering any semantic information of the node, but based on the structural property, like how this node is connected to other nodes in the network, we can identify that whether it is anomalous or not. So this identification, that whether we are going to identify based on some structural property, or we are going to identify the anomaly based on the attributes. Okay, see, this all depends on the given context and application. Okay, so this is a very important slide which tells us that there is no unique definition to anomaly detection. Okay, so there is no unique definition in which I can define, okay, this is anomalous. Okay, but based on the context and based on the application, we can have different anomaly detection algorithms. Okay, so this gives you a liberty of a huge research in this area. So in this area, you can have your own definition of anomaly, and then you can detect the anomaly in the data set based on that definition. Okay, so now let's move on and try to understand that what all are the different aspects that we need to consider when we are identifying anomalies in the graphs. Okay, so in order to identify the anomalies in the graphs, you have to first know, okay, what all are the different types of graph that I have. Okay, so now like what is your task? The task is to identify anomaly in the graph. Okay, now, in order to identify the anomaly, first and foremost, you need to understand that what all are the different types of graph we have. So, majorly, we can divide the types of graph into two types. One is the static graph and other is the dynamic graph. Can anyone tell what is the definition of dynamic graphs? Okay, just give me a second. Yeah. So, can anyone tell me what is the definition of dynamic graphs? We have already done in our last lectures.
It keeps which changing. Evolves over a period of time.
Yes, someone was answering.
it changes over the time.
Yes. So in the dynamic graph, we have a dimension of time. Okay, so here we have the snapshot of the data at a particular time. But here what we are doing is we are taking the snapshot of graph at different times. This is T1, this is T2, this is T3. For example, suppose I have access to Facebook data. Okay, so at maybe like in the year 2000, I have the snapshot of Facebook data. Then in the year 2005, I take another snapshot of the data. So during my snapshot of the data in 2005, there might be certain nodes that have been added. There might be certain nodes that have been deleted. There might be new connections that are formed. There might be the old connections that are deleted. Okay, so we can have these different changes at different times. So whenever we are considering different snapshots at different times, that is called as dynamic graph. On the other hand, when we are just considering one snapshot and we are then trying to analyze that snapshot, that is called as a static graph. Okay, so now after identifying this thing that, okay, these are the two types of graph we have. Now, next we need to see that how we can identify or how we can detect the anomaly. For that, you also need to consider another factors that your graphs can be plain or it can be attributed. Now, what do I mean by this? That graph can be plain or it can be attributed. So I might have a data set where I only have the nodes number from maybe 0 to 1000, and then I have an edge list. Okay, so I have an edge list which tells me, okay, 0 is connected to maybe 10, then 10 is connected to 20, 10 is also connected to 11, 10 is also connected to 1000, and so on. Okay, so in this particular data, you do not have any attributes related to nodes or edges. But I can have another data where I'm also considering the node attributes and the edge attributes. For example, in Facebook data, so there can be a situation I can have plain data where I'm only considering the nodes and the connection, and there can be a data where I'm also considering the attributes. For example, the area of a person or the college from which that person did degree or the company in which this person is belonging to, the number of times this person is logging into Facebook, and so on. Okay, so these are the different attributes that can be considered while detecting the anomalies. Now in dynamic graph also we have plain graphs as well as attributed graphs. But there is very less research that is done in this branch, attributed dynamic graph. So if you are searching for some research problem, you can look into this branch. Okay, so you can start looking into the algorithms in all these different areas, and then you can, design new algorithm and new definitions in the attributed dynamic graphs. Okay, so now after considering the type of graphs and after considering the attributed and plain graphs, so now next we need to consider that what all can be different properties that need to be considered when we are detecting the anomalous behavior. So firstly, we need to consider the structure. Okay, so I have this node and along with this node, I have to see what is the structure along like what is the neighborhood and how this node is connected to its neighborhood. Okay, so whenever we are considering the structure of a node, okay, so that can be considered as one set of algorithms. Then after that we might have communities, so I might detect the communities in the network. Now after detecting the communities, I might try to see, okay, what is the degree of all these all the nodes in the degree, what is the betweenness centrality of all these nodes, or so on. So based on those properties, if someone is behaving differently, we can categorize that particular node as anomalous. Okay, so after considering the community information, we can also consider the relationship between the data. Okay, so how relationship between the data? So for example, you have maybe a spam page. Okay, you know that this is a spam page. Now you are considering that to which other pages this spam page is connected. So based on the relationship of a known spam page to the other pages, you can identify anomaly in the network. Okay, so this is the third category of algorithms that we have in this particular branch. Okay, so now in the dynamic graph, as like in the static graphs, we have something that is slightly different from what we had in the static graph. We have feature based. Okay, so you will be considering the features, the properties, or the attributes of the nodes or the edges in order to identify the anomalies. Then you might also want to decompose this entire network. Suppose you have a network of maybe 1,000 nodes. You might want to decide to decompose this 1,000 nodes into some 100 nodes. And from the 100 nodes, you want to analyze these 100 nodes and identify the anomalies. Okay, so this is called as decomposition based anomaly detection. Then we have the algorithms based on communities, as we have seen in the static graphs. Then we also have another variant in the dynamic graphs, and that is window based. So what is window based? So as I have explained you that in dynamic graphs, we have these different snapshots, T1, T2, T3, and so on. So these are the windows. Okay, so these are the windows. You might want to know that, okay, in this particular window, this particular node was having so and so attribute values, and in this particular window these attribute has drastically changed, so maybe this particular node is a anomaly. Okay, so in you can either consider in the dynamic graphs, you can either consider window based, community based, decomposed, decomposition based, or feature based. So these are the different set of algorithm we can have. So now again, like you need to consider this thing that there is no specific definition of anomaly. So anomaly detection, it highly depends on what problem you are solving in the network. Okay, so what is the application, whether आप एक Amazon website में anomaly detect कर रहे हो, या फिर आप bank website में anomalous behavior detect कर रहे हो. So based on like where you are detecting the anomaly, your algorithms will change. Okay, so yeah. So in this particular section, we are not going into much detail of any of the algorithm, but I am going to give you an idea. So this idea is going to help you in designing different algorithm in different situation. So given this situation, you should have this knowledge that, okay, what are the things I need to consider, and like what all are the properties based on which I can identify anomaly if I'm given a graph. Okay, so that is the purpose of today's lecture. So I will be quickly, giving you the overview of the algorithms in each category, how it works. And based on that algorithm, you will get a knowledge that if I have certain situation and if I have certain type of graphs, what are the different options that I can use to identify the anomalous behavior in such networks. Okay, so now let us discuss in detail about the static graphs, anomaly detection in static graph. Static graph we have already discussed. This is a single snapshot of the graph that we want to analyze. Okay, so now in the static graphs are of two types, plain and attributed. So we have already discussed this, that these are the two types of graph we have. In plain graph, we will not have any attributes associated with nodes or edges, but in attributed graph, we will have some attributes associated to nodes or edges. Okay, so in the plane graph, so firstly, in the plane graph, I'm going to tell you what is like structural based algorithms and how they work. Okay. So let us first discuss that in static graphs, if we have plane graphs, then how based on structural properties, how based on the structure, I can identify the anomaly. Okay, so the algorithms in this category can further divide it into two types. So there are two types of methods that are based on the structures. Okay, so the first one is feature-based and the second one is proximity-based approach. So what is feature-based approach? The feature-based approach is when you are extracting the feature from the network. So remember, currently we are considering static plane graphs. Okay, static plane graphs. So here we do not have any attributes that are associated to nodes or edges. Sorry. Okay, so here we do not have any attributes that are associated to nodes and edges. तो हम क्या करेंगे हमारे पास एक structure है network का. So from that network structure we are going to extract the properties of the network that we have studied in, like I think before midsem we studied those properties. So we have studied various properties like centrality, closeness, betweenness, degree, eigencentrality, then clustering coefficient. Sorry, just excuse me. Okay, so before midsem, we have studied that how given a graph, you can identify different properties like degree, betweenness, closeness, then clustering coefficient, and so on. So now in this approach, we will be using these attributes, and based on these attributes, we will identify anomalies. Okay. Then next comes the proximity-based approach. What will happen in proximity-based approach? It uses the graph structure to quantify the closeness of the node in the graph to identify it, whether it is an anomaly or not. Okay, so in this, we will have one node and we will try to see that how close this node is to another other nodes. So based on the proximity, I can identify that whether a node is anomalous or not. Okay, so in this approach, basically, we are going to quantify the distance. So if distance of a particular node is more from the graph, so then that can be considered as an anomaly. So the idea is very similar to the idea of outliers. Okay, outliers में आप इसमें you assume that this is the graph. Okay, somehow you are going to quantify the distance of the node. If distance is more, then you can categorize that node as an anomaly. So that is the proximity based approach. Okay, so now let us discuss in detail the structure based approach that is based on the feature. So we are first going to discuss the feature based approach. So in the feature-based approach, so we can identify the anomaly based on the node level properties. What are node level properties? We have already studied eigenvector, closeness, betweenness, local clustering coefficient, and degree. Okay, so based on these properties, you can see that whether there is a certain node that has a very low value or a very high value. So those nodes can be classified as the anomalous. Okay, so you might have also studied IQRs. This is a method in statistics. So anybody is aware of what is IQR? Interquartile ranges. So how do we identify outliers using IQRs?
We studied this in first semester. Yeah.
Yes, yes. So, what is IQR is like, suppose first I identify degree value. So maybe I identified degree values. Okay. So maybe there are maybe 1,000 points. Okay. So 1,000 points, I will divide it into quartile ranges. Okay. So this is Q1, Q2, Q3, and Q4. Okay. So this is the range This is the range where my 25% of the data resides. This is the range where, just a second, I'm doing some mistake, sorry. Okay, so in this we have, if I'm not wrong, we have something that is Q2. Okay, so 50% of the data will reside on less than Q2, and 50% of the data will be greater than Q2. Okay, that means that 500 values will be here and 500 values will be here. Okay, so now we will have Q1 and Q3. Okay, so that means that out of these 500 values, 250 will be in this range and remaining 250 will be in this range. Okay, similarly here, 250 values will be in this range and 250 values will be greater than Q3. Okay, so now what we do, we try to identify the interquartile range. Interquartile range is Q3 minus Q1. Okay, so now you will try to see, now you will try to identify the outliers using the IQR method. So how we identify the outliers using IQR method? This is the interquartile range. Okay, so now the outlier is Q1 minus 1.5 of IQR. Okay, so any value that is less than this value, any value that is less than this value can be considered as an outlier. Similarly, I'm going to define a range beyond which a node or a point can be considered as an outlier. For example, Q3 plus 1.5 of IQR. Okay, so any value that is greater than this value, any value that is greater than this value will be considered as an outlier. Okay, so or like this is one of the way. So you have these values and on these values you can apply the IQR method, and then you can categorize, okay, these might be the outliers or these might be the anomalous behavior, the nodes behaving like differently. So on the other hand, we can apply the classifiers as well. So you can have your linear regression or SVMs on these values. And then based on those values, you can classify that whether this is like anomaly or not. So then after considering the node level properties, so after considering the node level properties, you can also have the dyadic properties. So we have studied the edge betweenness, number of common neighbors. So these are a reciprocity we have not covered in our syllabus. So, but we have covered these two measures. So using this basically tells that what is the relationship between two nodes. Okay, this considers two nodes at a point and then it try to identify what is the relationship between two nodes. So using the edge betweenness values and number of common neighbors that each node has, one can identify the anomalous behavior. Then third method is EgoNet method. Anyone remembers what is EgoNet? What is EgoNet? Okay, so the definition of ego network is that we will have one node. We will consider a one hop distance from that node. Okay, so this is ego. This central node, the node that we have selected, is called as ego. Now we will consider the network of all the nodes that are connected to these nodes. Okay, so maybe, for example, these are the four connections that this particular ego has, and we'll also consider what is the network between its neighbors. Okay, and then after that, we might want to consider the ego network with two hops. Okay, so now I will consider the neighbors of these neighbors as well. Okay, so whenever you are considering a network, you are considering the local community or a local network of a node that is called as ego network. Okay, so you are considering this node, you are considering its neighbor and the neighbors of neighbors and so on. So this is called as ego network. So in the ego network, you might want to identify the principal eigenvalue or the total weight or the number of triangles. Okay, or the clustering coefficient, clustering coefficient of that particular community. So using those values, again, we can identify the anomalous behavior. Then node group. Again, you can consider a group of nodes. Okay, so based on some property, you might want to identify a group of node or communities, as we have like we have already studied various algorithms to identify the communities in the network. Now, after identifying the communities, you want to see that what all are the values of the nodes in this particular community. So remember, this is a plain network, so we do not have the attributes. So in the communities, we are going to again see the same properties, like what is the closeness value, betweenness value, and if any node is behaving differently, then that can be considered as an anomaly. Okay, so beyond this, you can also consider the property of the network as a whole. Okay, so you can identify the number of connected components in the graph. Then MSTs, you can find the MST and the weight of the MSTs, average node degree. So you might want to identify the average node degree, and like you might have a like ground truth data that, okay, so the average degree should be somewhere around this. Okay, but then when you are trying to identify the global property, that is the average degree of the network, it might deviate, and from that you might get an idea, okay, there is some anomaly in the network, and then you can like analyze in detail that what node can be anomalous in that network. Okay, so using all these properties, you can identify, using all these features and all these properties, you can identify the anomalous behavior. Okay, so this is a very simple method. Here you are not considering any attribute of any node or an edge. You are simply considering the structure of the network. Okay, so how the node is connected to other node, what all are the structural properties. Calculating the structural properties, you can identify the anomalous behavior. Just a second, class. Okay, so now I'm going to give you a quick overview of one of the algorithm, that is oddball algorithm. And this algorithm is a feature-based algorithm for static graphs, and it is a structural based method. Okay, so in this particular algorithm, first of all, we are going to identify the ego nets. Okay, then in the ego nets, we are going to find the patterns. Okay, and that most of the ego nets of the graph will follow those features. Okay, so now in this algorithm, first of all, we can identify the ego nets. I have already given you the definition of ego nets, and given a node, you can identify its ego network. Okay, once you have the ego network, you will try to find the patterns. So now this particular algorithm has given certain rules. Okay, so they have done the research, they have done various experimentation. I am not going to go into the detail of those experimentations, but based on the experimentations, they have extracted certain rules. Okay, that if this particular pattern is there, then that is an anomalous behavior. So we are going to see those rules in detail now. So when we are considering this type of algorithm, there are two things that need to be considered. These are the basic research questions. So what features should we use to characterize the neighborhood? Okay, so you know that okay, we have a node and then we are considering it neighborhood and the neighborhood of these neighbors and so on. Okay, so once I have this particular network, now I need, first question is that what will be the features, what is the feature that I should use, since we have so many features, we have seen in the slide, we have so many features. So which feature among these you should use to identify the anomaly? So again, that feature depends on the application. Okay, so it depends on application. Actually, this anomaly detection is kind of an open research problem. So it is an open research problem. So you can, use any of the method. You can form your own algorithm to identify the anomalous behavior. So this is the first question that one can consider, that what is the feature that we should use to characterize the neighborhood? And what does the normal neighborhood look like? Okay, and once you have this feature, you also need to quantify this thing, that what will be the normal node and what will be the threshold beyond which, like, I can say that okay, this is anomaly. Okay, so you need to define that normal neighborhood. So these are the two major questions you need to answer when you are trying to make a certain algorithm, or you are trying to design a certain algorithm that is based on this. Okay, so now coming back to oddball algorithm. So I have told you कि इसमें क्या होता है कि first we identify the ego network. After identifying the ego network, we are going to see the pattern along the ego network. Okay, so they have these rules. Based on the rules, we can say that whether a particular node is anomalous or not. Okay, so now what are these nodes? So first they say that if any node is behaving like a star. Okay, so in a network, if I have certain node that is behaving like star, that means that this node is connected to a lot of nodes, and there are very few connections between those neighbors. Okay, so if I have a star kind of node, then that node is an anomalous. Okay, so then they gave the second rule, that is, if there is a near click, if there is a near click behavior in the network, if there is certain node that is connected to all the other nodes and even its neighbors are connected to all the other nodes, so then that those nodes can again be considered as anomalous. Why? Because like in real world social networks, it is very difficult that everybody is connected to everybody else. Okay, so such kind of patterns are not something that actually exist in social networks. So if you have this kind of behavior, that is again that can be considered as an anomalous behavior. So you can see in these examples, we are seeing the structure of the network. So then they define something called as heavy vicinity. Okay, so this is the definition that is taken from their paper. So what is heavy vicinity? If a person I has contacted indistinct people in the who call whom network. Okay, so we have a calling network in which like people are calling each other. So if I have a node that has who has contacted indifferent people, then we would expect that the number of phone calls or the weight would be a function of n. Okay, so whatever like the number of calls are there or the weight of these edges is there, that should be the function of n. Okay, so if it is not the function of n, if it is some extreme value, if it's like very extreme value, then that particular node can be considered as anomalous. So extreme total weight for the given number of contacts would be a suspicion. Okay, so this can be due to faulty equipment, for example, that is force dialing these numbers. Okay, so that is called as heavy vicinity. So you are going to consider a node, you are going to consider its edges. If the total weight of the edges is extremely high, then that is considered as a anomalous behavior. Then we have the third type of anomalous behavior, that is dominant edges. So if I have any edge that has a huge weight, so that can be again considered as anomalous node. Okay, so yeah, so in these in this particular algorithm, although like I have not kept the snapshots of the algorithm in this particular slide, but just for your reference, so these are the attributes that they have considered to design their algorithm. So if you are interested, you can look into that paper. They have considered the number of neighbors of each ego of each node, okay, that is degree. Then they have considered the number of edges in the ego network. What is the total number of edges in the ego network? Then they have also calculated the weight in the ego network, total weight of the edges. And they have also calculated the principal eigenvector of the weighted adjacency matrix of ego network. Okay, so using all these four values, they have quantified the click star heavy vicinity or dominant pair. Okay, so these are the values that they have quantified using these basic attributes. Okay, so after understanding the feature-based approach, we move to the next approach, that is proximity-based approach. Okay, so in proximity-based approach, you are somehow going to identify that whether a node is near to another node or not. For this, like there is a very popular measure that is called as personalized page rank. Okay, so you can look into this in detail. So using this particular measure, it's slightly different than page rank algorithm. So in page rank algorithm, we have something called as random walks. So, but in personalized page rank, we can, in the random walk, we can visit one node again and again. Okay, so using that, you try to calculate the proximity of the node to other nodes. And in this, we have covered this page rank algorithm. We have covered, if you remember, in your topic of this link prediction. In link prediction, we have predicted the links on based on the similarity of two nodes, that how similar the neighborhood of two nodes is. Okay, so in order to calculate the similarity, how many neighbors, if I have two nodes that are not connected, how many common neighbors are there? Okay. So in order to identify the number of common neighbors, we have used something called as proximity, the Jacquard proximity, and there were other proximity measure, for example, cosine similarity, or we have Adar-Adamic measure. And there were different measures that we have used there to calculate that how close this node is to this node. Okay, so these nodes, although they are not connected to each other, but we can quantify their closeness by using these proximity measures. Okay, so it tells us that how close this node is to other node. In the link prediction, we use the closeness measure to identify that whether there can be a link between this node or not. So in this particular algorithm, we can use these measure to identify the distance between the nodes, and using that distance, then you can identify a threshold, and based on that threshold value, you can categorize the nodes as anomalous or not. Okay. So then we have the static graphs. So we have covered the plane graph, structural based. Okay, and in structural based, we have further seen two types of method. One was feature based and other was proximity based. Now, next we are going to discuss the community based method. Okay, so community-based method, it relies on finding densely connected groups of close by nodes in the graph and spot the nodes or the edges that have connection across communities. Okay, so now in the community based method, one of the method can be that we will try to identify different communities in the network. Okay, so then we will try to see, okay, these are the nodes that are connected within. Then you know that using betweenness centrality, so using betweenness centrality, I can identify the nodes that are connected to other communities. Okay, so now I can have these nodes that are connected to other nodes through these bridges. Okay, and because this node is connected outside the community, so it might be considered as an anomalous node. Okay, so this is one of the method, community-based method to identify anomaly in the network. It can be thought that of as finding bridge nodes or edges that do not directly belong to one particular community. So in this, we assume that this particular node is not belonging to this community. It belongs to two communities since it is connected to other community. So that's why this node can be considered as anomalous. Okay, so now let's take a short break of 10 minutes and then I can discuss the algorithms that are remaining. Okay, so up till now, we have seen the different type of algorithms. So we have basically seen that given a graph, what all are the different things or what all are the different properties that you need to consider when identifying an anomaly in the network. So identification of anomaly, it depends on the nature of the problem you have in hand or the application that you are dealing with. So we have seen different types of algorithm in the category of plain, then structured, then community based. So let us more discuss on the community based algorithms. Okay, so here we have discussed the idea of community-based anomaly detection, where we try to identify the communities, and in the communities, we try to identify the bridge nodes, and the bridge nodes can be considered as anomalous. So now there is this algorithm, the paper is referred in the slide. So this particular paper it tried to identify the communities in the static graphs. So basically, what this paper says that there are several real world data that are bipartite. The examples are customer product review, like we have already discussed many times. The Amazon website, we have the reviewers who are reviewing the products. Then we have financial trading between the stocks and the traders. We will have different traders who are investing in different stocks. Okay, so this is a bipartite graph again. Then again, we can have the publication network where we have authors and papers. So in this paper, we try to identify communities in these bipartite graphs. So remember, this in these graphs, we cannot follow the traditional methods of identifying the communities. So we have to, look into the neighborhood of a node, and based on that neighborhood, we need to identify the communities in which it belongs to. So first problem here is how to find the community of the given node, which is also referred to as the neighborhood of the node. So in this type of problem, the first problem that you need to look into is that how you will identify the community. Okay, so that is the first thing. So जब भी आप ऐसा algorithm design कर रहे हो, तो this is one of the problem that you need to work on, that how you are going to quantify the community in the net. So once you have you have quantified the community, you have defined what is community in the network, then you need to quantify the level of the given node to be a bridge. Okay, so you have to define the level that a particular node is a bridge. And then if it is a bridge, you can categorize it as anomalous. So these are the two different problems in this method. So then there is this method. This is another paper that is community based. So in this community based algorithm also, the idea is same. You are going to identify the nodes that are the bridges, and based on that, you are going to categorize them as anomalous or not. So you can look into this paper if you are interested. So now, like after discussing this, we are going to move on to attribute-based methods. So now remember, now what all methods that we are going to consider, we are going to consider the nodes, the connections of nodes, and there will be certain attributes of nodes, and there can be attributes of edges as well. Okay, so these are optional. So yeah, so now like along with the node and the edges data, you are going to have additional data that is related to the nodes or edges. Now using those data, using that semantic, you are going to identify the anomalous behavior in the network. Okay, So now the static attribute based graphs, they can be further, there are further two categories of algorithms that can be used to identify the anomalous behavior. One is the structured based and other is the community based. So in the plain graphs, we have already seen the structured based methods and the community based methods. The idea is somewhat similar here, but the only thing is here you also have to consider the attributes of the nodes to identify the anomalous behavior. So these method, it exploits frequent substructures and subgraphs pattern to spot the deformation in these patterns. Okay, so in this we try to identify the subgraphs or the substructures, and in those substructures we try to identify the anomaly based on the attribute values. Then we have community based methods. In community based method, you spot what is the community outlier that do not exhibit the same characteristics as the other community members. Okay, so in this, like you will identify the community and then you will try to see, okay, which is the node that has properties different from all the other nodes. So those nodes are identified as the anomalies. Okay, so in these algorithms, there are these two types of problems that need to be considered. So the first problem is finding the unusual substructure in the given graph. The second problem is finding the unusual substructure among the given set of subgraph in which the node and edges attributes are unique or non-unique. Okay, in which the attributes are different. So these are the two problems that you need to consider when you are identifying the anomalies in attribute-based graphs. Okay, so now like let me discuss these community-based methods. So how do we identify the community-based outliers? So firstly, we try to identify the communities. For example, like I have this community of football players. Okay, so now in those football players, I try to see their attributes, that whether they smoke or not. Then like I identified that maybe, okay, if there were 20 players, then among these 20 players, only two players are there who smoke. So these two players have different property than the entire community. Okay, so because these two nodes have different property, or these two players have different property, so they can be considered as anomalous. So in this category again, we have these different algorithms, CODA, and this is Gout rank. So these are the different algorithms. So now I'm going to discuss in I'm going to briefly discuss the algorithm that is Focuso. So in this algorithm, we try to identify the community. Okay, then there is something called as focus attributes. Okay, so given the initial set of attribute provided by the user, the approach first identify the subset of attributes that the given node agrees on. Okay, so there, like if there are suppose 10 attributes, then amongst those 10 attributes there will be two attributes that define the community. Okay, there will be two or three attributes that define that community, and that those attributes are similar for all the other nodes in the network. Okay, for example, for all the students who are studying in this class, for all of you, like your attributes like section is same. Okay, and might be like you might belong to like similar company domain. Okay, so there can be a few attributes that are similar and rest of the attributes may be different. Okay, so for example, age may be different, or the area from which you are joining may be different. So now you have to ignore all the attributes that are different, and you have to only consider those attributes which are defining this community. So those attributes are called as focus attributes. Okay, so now in this particular example, I have this community. In this community, we have the two attributes that are considered as focus attributes. That is the place of the student, and the degree of the student. So we can see that in this particular example, most of the nodes, they have PhD. And there's only one node that has college degree. So because this node has a different property, different focus property, so that's why this node is considered as anomalous. Now find the cluster of densely connected nodes in the graph that also agree on the attribute called as focus cluster. The outlier is defined as the node which belongs to a cluster structurally but deviates from its focus attribute. So structurally, this particular node might belong to this community, but then attribute wise it is different. So that is why it is considered as an outlier. Okay, so this is how we considered the structural properties and the community properties in the attributed static network to identify the communities. Okay, so then there are different algorithms in which you use the relation learning. Okay, so as I have given you the example in the starting of the lecture that there might be a page and there can be another spam page and these two spam page are connected. Okay, so now like I am going to use this connection or this relationship between the spam pages to identify that what all other pages can be the outliers or the anomalous pages. Okay, so now let's go through this slide. It exploits the relationship between the object to assign them into the classes that is anomalous or normal. Okay, so what it does, it exploits the relationships. Okay, so it uses the relationship between nodes. So it is going to use the edges or the attribute of edges to identify anomalous or normal behavior. Different different from proximity-based approach, which aims to quantify autocorrection among the graph object. The spam pages link to another. Okay, so I have already given you this example, and there are different algorithms that uses these properties, the edge property, to identify the anomalous behavior, and these are the different algorithms. So you can see that most of these algorithms are naive-based models, okay, and logistic regression. So using these techniques, you can use the relationship between the nodes and you can identify whether it is anomalous or not. Okay, so yeah, with this, we end the discussion on this topic. I have not given you the detail of much detail of this topic here. Okay, but we have like at a high level, we have discussed all these methods. Okay, so now for today's class, my aim was that you should know that, okay, this is one of the branch of the problems in social network analysis, that is anomaly detection. So then we have tried to understand how important is anomaly detection problem, and we have tried to understand that like there is no specific definition ki anomaly kya hai. Okay, so because there is no specific definition ki anomaly kya hai, so like we need to know different aspects that can define anomaly in the network. Okay, so for that we have seen ki whether, first of all, we need to consider ki whether graph is static or dynamic. After considering that fact, we have to see ki whether us network mein I have the data related to nodes and connections only, or I have attributes as well. So if I have only nodes and connections, then I will try to use the network properties, use the features, use the communities to identify the outliers in the network. On the other hand, if I have the attributes associated with my network, okay, so then I can use both the structural properties and the attribute values to identify the anomalous behavior. Okay, so yeah, so we have seen the different strategies or different techniques you can follow to identify the anomalous behavior in the network. So yeah, so now next, like I am planning to discuss, like revise what all we have done before mid-sem. So up till now, do you have any doubts? Anyone wants to ask anything? Okay, so then I will start with the revision of the syllabus that was covered after midsum. So let's see how much we can cover in this.
Ma'am, I have a quick question. Are we done with all the topics that were supposed to study for this semester?
Yeah, we are mostly done, but like I am planning to introduce another topic as well, recommendation systems. So I
Okay,
want to give you like a quick a review of that topic as well. But
all
again,
right,
we are not going to go in much detail in that topic because like going into much detail is again beyond the scope of this course, right?
all
We
right,
need to
all
have
right.
another scope. But yeah, I want to introduce you with all the problems that are there. कि इस subject में major क्या है? Okay, so you should have that kind of idea. कि given a social network, what all are the different aspects you can see in this social networks? So what all are the different algorithms you can see? So what all are the different perspectives from which you can see the data set? So that was the whole idea of this subject. So given a network data, what all I can analyze, how I can analyze, and what all are the application of those techniques. So that was what we tried to cover.
Okay, ma'am.
Okay, so let me open lecture number 7. So in next lecture also, for the first half, I will try to cover the recommendation systems. And in the second half, we will revise the syllabus that was there like before midsem. Okay, so this is lecture number 7. So we have, I think, started from this lecture after the midsems. So in this lecture, we have studied homophily. So first we started with homophily. So we have studied key in the social networks. Naturally, like people tend to, connect with the people who have similar properties. So this property is called as homophily. You tend to, go along or you tend to work along or you tend to hang out with those people who are similar to you. So this property in the network is called as homophily. Now, homophily is the reason why there are communities in the network. Okay, so homophily is one of the property that exists in social networks because of which we have communities. Whereas, like if we see the random graphs, in the random graphs, we have the connections, but we do not have the communities in the random networks. So, yeah, there was this experiment done where, like in 1930s, so very early, this experiment was done on a classroom setup where like a researcher tried to identify the relationship between the nodes. And then he came to a conclusion that these relationships are not just random. Okay, so they are because of this property called as homophily. And homophily is that people who are similar, they tend to connect with each other. Okay, so then in this lecture, we have gone through the definition of community. What is community? Community is the subset of nodes that are more connected within than the rest of the network. We have seen that this community detection has a huge application. So by now we have covered a lot of topics like this link prediction. Link prediction, maybe we have seen that community is used to predict the links. Okay, so then we have also seen in today's class anomaly detection. In anomaly detection also, one of the major part is identifying the community. So this forms the basis of a lot of advanced algorithms in this area in social network analysis. So yeah, so that's why identifying the community is a very important property. So if the communities are not identified, the networks, the huge networks are a hairball-like structure. So our aim is to divide the network into these communities and then try to understand and analyze the properties of these networks. Okay, so yeah, then like we tried to quantify that this is a difficult problem and how this is a difficult problem. And then we have seen that communities can be of different types. So we can have disjoint communities. What is disjoint community? Disjoint community is the one जिसमें nodes overlap नहीं करते. Okay, so if we have like each node belongs to just one community, so then that particular type of community is called as disjoint community. Then we have overlapping communities. So this type of communities are more realistic. In the real world, we tend to belong to different type of community, right? So we do not belong to a disjoint community. We tend to belong to different communities. So we have different algorithms that can be used to identify disjoint communities and to identify our overlapping communities. But then identifying overlapping communities is a slightly difficult problem, and there is a separate set of algorithms that are used for this. Then we have seen that apart from this, there is also something called as hierarchical community. Hierarchical, as the name suggests, it is that like within the community you might have the communities. So such kind of communities are called as hierarchical communities. So whatever methods are used for your disjoint communities, they can also be sometimes used for identifying the hierarchical communities. Then we have studied about local communities. Local communities are what we have studied today in the class, ego networks. So when we are considering a node and then we are considering what all are its neighbors and what all are the neighbors of neighbors, and we are trying to study the network, the subgraph that is induced by these nodes, that is called as a local community. So then these were the different category of the algorithm to identify the communities. And then like we have studied that initially the community detection was based on the node centric measures. Okay, so what were these node centric measures? So firstly, we tried to identify the clicks in the network. Okay, but identifying the clicks, what are the clicks? Clicks are that when a node is connected to all the other nodes in the network. So, but identification of click is an NP hard problem. So this condition has to be relaxed. So this condition was relaxed by using k-clicks. What is k-clicks? K-clicks is we try to identify the maximal subset. So the definition of maximal subset I have in detail explained you in the class. So in this, the subset of the nodes should be maximum. No extra node can be added in that subset. Okay, and then if k click, if I'm trying to identify two clicks, then the maximum distance between any two nodes in that maximal subset should be maximum 2. Okay, so this was the definition of k clicks. Then we have k-clan. Okay, the difference between k-clicks and k-clan is that the induced subgraph. Okay, so it should not take help of any node outside, any node that is outside this subgraph in order to identify the shortest distance. Okay, so this was a slight difference between k-click and k-clan. In k-click, for example, in this particular subgraph, if I want to go from 3 to 5, okay, I can use 4. 3, 4, 5. So this, the distance between 3 and 5 becomes 2. But in this definition, we cannot consider that particular node. Okay, so this particular subgraph is a k-click, but it is not a k-clan. Okay, it is not a k-clan, two-clan. Then we started the definition of K clubs. K clubs, it releases the definition, it releases the restriction of maximal subset. Okay, so in this, we do not have maximal subset condition. Okay, then we have studied another node-centric community detection that was based on K-plex. So the important thing to note here is that the definition here, the subset of vertices in a graph is called as k-plex if every vertex of the induced subgraph has degree at least s minus k. So the definition here that the degree at least S minus K, at least is very important. Okay. So based on that, you can identify the value of K in the K-plex, and using the K-plex value, one can identify the communities. Then there was this core definition. So in core definition, what we do, first we remove all the nodes that have degree 1. Okay. And then we keep on increasing this K value or the degree value in order to remove. And based on that, we identify the communities. Okay, so these were the measures that were based on node properties. Then we also have the measures that are based on the edge properties. So here we studied that we can use cut to identify the communities. But sometimes when we straight away use the minimum number of edges that can be disconnected in order to make the graph disjoint, it might lead to an unbalanced graph. Okay, so here I have unbalanced community. One community has just node 9 and the other community has all the other nodes. So in order to avoid this, we need to use ratio cuts and normalized cut. Okay, by using the value of ratio cuts and the normalized cut, you can have the balanced communities. Then we started the Greiman-Newman algorithm. This algorithm was based on your edge betweenness. So we know that there are certain edges that join two communities. So these edges have high betweenness value. So we try to remove all the edges that have high betweenness value, and we have this assumption that, okay, if we'll remove such edges that have high betweenness value, then eventually we will have the communities or we will have the disjoint networks. Okay, so in this algorithm, what we do, we first find the edge betweenness of all the edges. Then we sort the edge betweenness values, and then we remove the edge that has highest betweenness value. So once this edge that has highest edge betweenness value is removed, just a second. Okay, so once this edge is removed, then again we need to calculate the edge betweenness of all the remaining edges. So since the calculation of edge betweenness is itself an expensive operation, so this particular algorithm is not good for large graphs. Okay, so now there was another measure called as modularity. So next we studied that whenever we have large networks, we cannot use edge betweenness method or the other node centric measures. They are expensive to compute. So in those cases, we use the modularity measure in order to calculate the quality of the clusters. So based on modularity maximization, one can identify the communities. So now let's discuss the next lecture. Okay, so next we studied the modularity based algorithm. So in the modularity based algorithm, we have discussed in detail that how we can calculate the modularity. Okay, and we have discussed that modularity value ranges between different values. So higher the modularity value, stronger is the community. So based on these values, we will first try to calculate the modularity for the partitions. And then based on the modularity value, if it is high, we can say that, okay, this particular partition is good, or these have strong communities. Then we have seen that for the numerical purpose, we use this particular formula in order to calculate the modularity. So this is a slight variation of the formula for calculating the modularity, where LC is the number of edges inside the community. So we will have these communities in the partition. Now, like for each community, we are going to calculate the number of edges inside the community. Then M is the total number of edges, and DC is the sum of the degree of nodes in the community. So using this formula, you can calculate the modularity of a particular community. And the modularity of the entire network will be summation of all modularity of all the communities. Okay, so then like this is an example for like how you're going to calculate the modularity value. Then, like these were the algorithms that we have discussed, that how using the modularity value, you need to maximize the modularity. And this is an iterative process. This is a greedy method. So using the greedy method and the iterative method, I have explained you in detail that how we will try to, try to optimize the modularity value in this algorithm. So for these, we have two algorithm. One was fast greedy algorithm and the other was Levine algorithm. And this was the limitation of the modularity based algorithm. One was the resolution limit. What is resolution limit? It says that whenever we have well connected nodes, for example clicks, so it is difficult to identify such community. So in other words, a resolution limit says that it is difficult to identify smaller communities using modularity method. Okay, so yeah, these were the methods that we have discussed for calculating the communities. So let me check lecture number 9. Okay, so in lecture number 9, we started with the link predictions. Okay, so now like we have seen that how do we calculate the communities in the network. So for identifying the communities, we have seen node-based measures, then we have seen the edge-based measures, and then we have seen the modularity-based methods. So these were the three broad type of algorithms that we have seen when we were trying to identify the communities in the network. So then next we started our discussion with link predictions method. So we have seen that like even link prediction has a huge application in various different domains. Then we have seen that link prediction problem can be divided into two types. Okay, so one type of problem was when we are given a graph and that graph is incomplete and we are trying to predict the missing links in that graph. Okay, so that is one of the method, and this method is on static network. Okay, so in the static network, there might be certain links that are missing, and then whenever we try to identify those missing links, that problem is called as missing link prediction. Other variant of link prediction is future link prediction. So in which we are given the dynamic graph in which we are given the graph at different timestamps. And in this graph, now we try to, identify what all will be the edges that are not there in this particular timestamp, but will be there in the next timestamps. So these are helpful in recommendation systems. So then this is the definition of link prediction model. And we have seen that link prediction problem is a challenging problem. Why it is challenging problem? Because like there are a huge number of edges. Okay, so there will be for like 100 nodes, there are total 4950 edges. So amongst these edges, actually there will be order of V edges in the actual graphs. Okay, so actually there will be only approximately 100 edges that will be present in the social networks. So we have these many false cases. Okay, so because we have a lot of negative sample, therefore this problem becomes very challenging. And this is an example of class imbalance property. So then we have seen that how you will evaluate such a imbalanced classification problem. So this is basically a classification problem. This can be thought of as a classification problem in which we tried for each particular edge, we try to classify that whether it is whether we try to predict that whether this is an edge or not. Okay, so now like whatever classification method we are using, we need to have an appropriate method for evaluating that. Then we have seen that we have this confusion matrix, and we have seen various different measures. We have seen accuracy, precision, recall, and we have discussed that accuracy cannot be used. Okay, so accuracy cannot be used, and I have explained you the reason why accuracy cannot be used. And then there are these different measures that can be used in order to evaluate such a class imbalance property. Okay, so these were different algorithms, and we have seen that one of the best suited method for evaluating link prediction method is AUC ROC method. Okay, so then like after studying about how to evaluate link prediction methods, we next started the discussion with like what all are the different algorithms in link prediction. So the different link prediction algorithms can either be heuristic based or probabilistic model or theoretical model. So in these algorithms, we have not discussed the theoretical models, although like we have tried to cover these two categories, the probabilistics and the heuristic methods. Okay, so then in the heuristic method, we have studied that based on the node similarity. So how you will calculate the node similarity based on the number of neighbors that are common. Maybe we can consider the metadata related to nodes. So based on these similarities, how similar two nodes are, or based on the metadata or based on the number of common neighbors, we can predict the link. If more similar the nodes are, the probability that these two will be connected will increase. Okay, and then we have the heuristic methods can be divided into these three different categories. One is the local heuristic, global heuristic, and quasi-local heuristic. Okay, so in the local heuristic method, we have discussed all these different similarity measures. Okay, so there are these different similarity measures, and all these similarity measures are based on common neighborhood. But the only difference is in the formula. There is a slight difference in the way we normalize the common neighborhood. Okay, so we try to identify the number of common neighborhood and we try to normalize that value, and then we try like for each edge, for each non-connected pair of net, we are going to calculate these values. Okay, we can choose any one of these local similarity method, and we are going to calculate that for each non-connected edge. Okay, and then we can order those values in the descending order, and then we can keep a certain threshold that okay, maybe the value, if the value is greater than so and so value, then I will predict these edges to be present in the network. So this is how the local method work. So we have seen all these different, like each of this formula is considering the common neighborhood. Only difference is in the normalization, the way we are normalizing the data. Okay, so all these are the different formulas. Then in the global heuristic method, we have seen the CARTS score. Okay, so CARTS score, it basically it consider the number of paths, the length of the path, the length and the number of paths that are there between a pair of nodes. So based on the number of paths between two pair of nodes, we can predict whether like an edge will be there or not in these two particular nodes. Okay, so this is again, card score can again be used in anomaly detection as well. So this is something that is quantifying that how close a particular node is to other nodes. Okay, so using this type of measures, like you can again, you can design your own anomaly detection algorithm. Okay, so then we have seen in the global heuristic, we have seen different other different formulas. That was the hitting time. In the hitting time, we have considered the random walk. So we have seen that we are randomly walking in the network. And if we randomly walk in the network, then what is the probability of reaching from one node to another node? What will be the hitting time? So we are going to calculate the expected hitting time, and using the expected hitting time, you can calculate these two measures. Okay, so now there was a slight difference between the global heuristic method and the local heuristic method. The local heuristic method, they consider only the local property when we are trying to predict that whether there will be an edge or not. And the global heuristic method, on the other hand, it is going to consider the network as a whole. So that's why global heuristic method were more reliable when we are trying to calculate when we're trying to predict that whether there will be a links or not. Okay, so yeah, now let me open the next lecture. Okay, so this is the 10th lecture. So in the 10th lecture, we have seen the difference between the local method and the global method, which I have already explained you. And then we also try to, we also saw another method that was probabilistic based. So in this particular algorithm, we try to use the generative model and we try to identify the probability that is associated with each of the nodes that are not connected. Okay, so based on the probability, you will form the dendrograms, and then you will identify the probabilities, and based on the probabilities you can identify that whether there will be connections or not. So yeah, so then we started with the diffusion models. Okay, so the diffusion models, and after diffusion models we have the I think we have discussed the anomaly detection, right? So yeah, so these both are the topics that we can revise in our next lecture. Okay, so yeah, anybody, any question?
Ma'am, but you said like the next lecture we are going to review the topics that is previous to midsem, right?
Yeah,
So
previous to midsem, the topics are very straightforward. Like now we have considered, now we have covered quite advanced topic as well. So these topics, though they take time, वो earlier वाले topic तो वही है ना, like we have seen the degree calculation and the centrality calculation is there. So there are, I don't think that should take much time. And the initial few lectures, they were mostly theoretical. So,
oh,
yeah, so in the exam, you should consider more of the numericals.
sure,
So
sure.
there
Thank
will
you.
be less of the theoretical part given, and more focus will be that whether you really understand the concept or not, and it will be more on numerical based.
Okay, got it. Thank you.
Yeah. Okay, so with that, we will end this lecture. So thank you, everyone. Thank you for attending, and we'll meet next weekend now. Thank you. Bye.
Thank you, ma'am.
Bye.
Thank you. Thank you.